Hey everybody, welcome to today's session. We'll get started here like we did yesterday, probably in about 3 minutes. So thanks for joining and we'll talk shortly. Hey everyone, good to see you back from yesterday's session. We'll get started here in just about another minute or so. Give everybody else a few moments to join and then get started. All right, so why don't we go ahead and get started here? Some people might join, if not, they're lost. So welcome back. I think everybody joined us yesterday. If not, doesn't really matter. It's a new session. My name is Josh Broltheim. I am the training manager at Sumo Logic, and I'm going to be leading today's session. Yesterday's session was led by Odell, who did a great job, and he's going to be assisting today. So if there's any questions or questions, feedback, thoughts during the session, go ahead and post those in the chat, and Odell will grab them and we'll reference them as appropriate. Let's go. Let's do it. So today's topic is observability fundamentals. And during the session, what we're going to be going over is our observability solutions first. So what is it? What are the components of it? We're going to talk about 3 pillars of the observability solution. It's going to get a little repetitive with the 3 pillars. You'll hear that referenced a few times, but the idea that logs, metrics, and tracing combined, those pillars form an observability solution, and what that is, we'll talk about. We'll look at some tools and technologies as it says here. So we'll look at or utilize Root Cause Explorer, which is a feature in Sumo. We'll also do some tracing as well, which is another feature in Sumo. So we'll use those and see how they play into the observability story. Our schedule is very similar to yesterday's in the fact that we're together for 3 hours. The first 2 hours are content, labs, slides, etc. The last hour is the exam, and so that's kind of the same pattern here. As far as the specific agenda, this is really granular here, but essentially we're going to do some slides, we'll do some labs, we'll do some slides, we'll do some labs, and then we'll take the exam. We'll take a break again, probably about in top of the hour, maybe a few minutes after, just depending on where we are in the labs and if we're going to, finish it or stop midway or what have you. But we'll put that break in, we'll take that exam, and yeah, should be good. As a reminder, and I don't think anybody really forgot, is the Uber Eats promotion, and I'll go ahead and put that link in the chat now. I'll put it in later as well, but just in case any of you didn't get a chance to take advantage of that yesterday, you'll have that link handy. So as a reminder, take the exam, pass it, and you earn your certification, and you also earn a $15 Uber Eats voucher. If you're in India, we are doing a promotion with Swiggy, so you still get free food, just a different vendor. But I think everybody knows the deal on that. All right, so let's dive in and start to talk about what is observability. Now, this first slide of what is observability, there we go, is not specifically observability, but is more specifically Sumo Logic. And I believe Odell went over the slide yesterday. What we're showing you here is Sumo Logic's continuous intelligence platform and how Sumo can help you yeah, all the benefits of Sumo. At the top of the screen, we have a couple different dashboards that are representing different uses of Sumo Logic. You can use Sumo Logic to gain insight into your operational intelligence, more security intelligence side of things, maybe business intelligence, global, if you're doing campaigns and seeing how those are going on a worldwide basis, you can go ahead and utilize Sumo Logic for that. Now, for today, we're going to be talking about really observability in Sumo Logic, but of course, Sumo Logic has many other uses. Now, what data can you utilize in Sumo for observability or just period? Well, any data anywhere in the world. Your data might be in apps, it might be in the cloud, it might be in servers, it might be a bunch of other places. And essentially, you need to bring that data into Sumo Logic, and then it's collected, and then you can start to utilize it. And if you joined us yesterday, we went over collection and collecting the data and bringing it into Sumo Logic. And so then the data is all in Sumo Logic. Once it's in Sumo Logic, as we looked at a little bit yesterday, not too deeply with the analytics, but you can start to do things like run advanced analytics, utilize APIs. Everything is multi-tenancy and scalable and elastic, so it can go ahead and stand up, get stood down quite quickly or instantaneously. And so all those benefits of Sumo, I feel like you probably are well aware of. Our attestations and certifications on the right, Odell pointed those out yesterday because he was proud of them, and I am too. And so as a reminder, these might be a little US centric, but we have our HIPAA, our PCI, that FedRAMP, that's a big one, and they're all up to date. And then, of course, who can benefit from Sumo Logic? Well, we're a little focused on DevOps today, but anybody can benefit from Sumo. And so regardless if you're in DevOps, engineering, et cetera, yay, Sumo can work for you. So, but let's get into observability because that's really why we're here. We're not here to really pitch Sumo. You know the benefit of it already. But what is observability? That's what I want to talk about. So observability, there we go, is the ability to observe, and I know I shouldn't use the word in the definition, but observability is that ability to observe and understand the whole state of an application, such as our coffee app. So what we have here, we'll use this example a few times throughout today, is Sumo Logic Coffee. And imagine we are a vendor of coffee, very similar to a company that has a green logo, and we sell coffee around the world, and we have an app that people use to order coffee. So imagine that scenario, and we'll use that scenario, like I said, a little bit later as well, but for now, the basis of that is good enough. So we have this coffee app. Now with observability, what we want to be able to do is observe the app from the outside and understand what's happening. And what's happening inside is going to be important. So we want to be able to observe from the outside and understand what's happening on the inside. And observability is going to make sure and help us ensure that the app is running reliably, excuse me. And in other words, the system is up and running, functioning well, and is secure. Observability is going to make sure that our apps, their resources are going to be used and accessed as intended under all the circumstances. And so what we're starting to show here is the idea of the observability workflow, I guess we could call it, is you're going to use, or the system's going to be utilizing observability to start to look at the app. If something goes wrong, notify and alert whomever is appropriate. Using the tools we're going to look at today, or some of the tools, start to make conclusions about what is occurring using Root Cause Explorer, using tracing, and then you're going to take an action. And then you're going to probably repeat that action or repeat that process, excuse me, multiple times throughout the day. So this is what observability is and how it's starting to help us. Now, I alluded to the three pillars of observability just in the intro, and it pops up pretty quickly in the slides. And so what we have here is the idea of our logs, our metrics, and our tracing all coming together to complement each other and be used together in a single platform. And so in a single product, you're going to find more benefit or more benefit than having them in three separate products. So if you had your logs in one environment or one product, your metrics in another, your tracing in another, it's hard to kind of tie everything back together. Well, fortunately with Sumo Logic, all one product goes in, and now you can start to observe it. And we'll, like I said, we'll start to observe data or utilize the observability solution within Sumo pretty soon within the labs, probably about 20 minutes or so. A few more slides though, so the front of this class is a little slide heavy. So what is the need to have an observability solution? And what I wanted to talk about here is, why is observability important? Well, what we're stressing or showing the importance of is reliability. And reliability, as it says here, is the foundation of the customer experience. And what we want to do is have the best customer experience possible. And so reliability is going to be important to facilitate that. Now, when we're talking about reliability and reliability, excuse me, we're talking about three, well, they're also pillars, but three things that really support that customer experience. And reliability is also that new requirement of applications. So when enterprises deliver new applications, they have to ensure that they're going to be highly available, that they're going to be performant, and that they're going to be secure. And there's going to be real business impacts if those do not occur or you are not delivering high performing apps. So for example, some stats to kind of drop on you here. So in regards to availability, well, we've seen, and we have numbers to back this up, that 100 microseconds, so a tenth of a second of downtime, is going to reduce e-commerce sales by 1%. And this occurred for a well-known content delivery network service provider. So, having that availability of a tenth of a second reduce sales by 1%, and that's quite meaningful, quite important, and quite something you want to avoid is that downtime. In regard to performance, you might be available, but if there's latency, that's also going to be a problem. It's been proven, or we have the stats once again, that a half-second latency result in drop traffic by 20% for a search engine giant. So just because the system was a little slow, even though it was available, people are impatient. They didn't want to wait, and they saw a significant drop in their usage. And then security. I don't think we have to stress the importance of security and why that's fundamental to customer experience. But as an example, DDoS attacks, denial of service attacks, are anticipated to double to 14.5 million by 2022, and we probably need to update that stat because we're in that year already. And so these are all things that you or your organization are going to be concerned about, because you want to make sure that you're able to ensure reliability, and doing so through a unified platform can help you start to monitor the app, diagnose it, and then fix it. And so that's why the need for an observability solution is there. Once again, I feel like you probably know why an observability solution is important, but if not, those are certainly a couple good reasons. This next slide, it's probably a little picky or a little subtle, but I thought it was important enough to put in as well. And what I wanted to do here, and it's just a pretty quick slide, I don't even think this is on the exam, but just I wanted to talk about the difference between monitoring and observability. Because at face value, they kind of seem to be the same thing, but they're a little bit different. And I just want to mention that and then kind of clarify that terminology as we go forward. So as I said, a lot of people equate observability to monitoring, but when we dig deeper, it's not just about seeing when something goes wrong, but about what's causing it, what areas it's impacting, how can we correct it before it impacts more customers. So how is observability different from monitoring? Monitoring is about telling you the state of a system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored or hasn't been configured to be monitored, then we have no idea what's happening there. And knowing something is wrong, of course, is quite important. Now, with monitoring, you know about the functioning of your apps that you've configured to monitor, but you need to know more about the growth and the utilization. And this is where observability comes in, because it goes beyond that monitoring. It brings together those logs and metrics and traces, those three pillars, to give us a broader view and a deeper context. In this case, with observability, we know something is wrong, and we're able to, or going to try to be able to figure out why, what has occurred. So little terminology definitions there. All right, let's see. We still have a few more slides here, but then we'll get into some hands-on. All right. So this is this is a good view of, I like this one as well. What we wanted to show here is the idea of why Sumo Logic's observability solution. So hopefully through those couple of slides I just did, I sold you on the importance of having an observability solution. And I think you know the importance of it because you want to be able to observe your system. Now, why is Sumo Logic the best, or one way to go at least? Well, there's going to be two key requirements for an observability solution. First, the observability solution is going to be able to, or should be able to, handle large-scale data sets. So while monitoring and diagnosing requires working with some amount of data, it's the troubleshooting phase where the observability system should be able to handle essentially unlimited amounts of data from logs, metrics, and traces. And this is a challenge for many observability solutions. However, fortunately for you, Sumo Logic, built on the cloud native architecture, is very easily able to ingest and store any amount of data in a highly elastic and flexible way. Now, secondly, the observability solution needs to be very scalable, or have a very scalable analytics engine. Observability is going to require you to analyze lots of data and machine learning and other initiative search-driven analytic capabilities. As a large-scale machine data analytics platform, Sumo Logic provides the out-of-the-box capabilities to support the ingestion and analytics for any amount of data. So what we're trying to show here is the idea of the amount of data and the amount of, or richness of analytics that you need, and how when you need that as you get deeper into the understanding of what's going on. So that was a terrible explanation. So let me try and use the slide here to show it. What we're trying to show in the middle there is an iceberg. And essentially at the tip of the iceberg is going to be a small chunk of the solution of what's going on, how to fix it. And if you want to just look at that top little chunk, you can just monitor your information. Now, as I just described earlier, monitoring is important, but it's not the full resolution. It's just going to show you that something is wrong. It's not going to show you where or why or how, just that what something is wrong. And that's great. We encourage you to monitor, everything should be monitored. But once again, you want to get a little bit deeper to provide the true observability solution. And so that's where we're going to need more data. So we're going to need to dig deeper in the iceberg. And by digging deeper, we can start to get more data, or utilize more data and get more data back as far as what might have gone wrong. And we can start to diagnose and understand where things went wrong, troubleshoot and understand why or how they went wrong. And that's what we're going to do today when we start to dig into those tools in just a few moments. We're not going to just simply look at the what, but we're going to figure out the where, the why, and the how. And using some very simple tools, you'll see how it works. It's really, you'll see the proof in front of you. All right, so that's about it for this slide. Let's see. This one it's starting to show the same thing again, the idea of the monitoring, diagnosing, and troubleshooting. And so these three tenets are important, and we use this structure of three throughout this class a few times, where we have our three pillars: the logs, the metrics, the tracing. Those all form observability. To get the best observability solution, though, there's going to be three portions of, as it shows here, the incident remediation process. You're going to have the monitoring. Once again, we just talked about monitoring, which is essentially just looking for things occurring, those alerts that are occurring. But then, of course, you want to resolve any issue or incident that's occurred. And so this is where you go deeper with the diagnostics and the troubleshooting. And we're going to look at those shortly. Now, with it, the diagnostics, as it says here, You can utilize Entity Explorer, Trace Analytics, Metrics Explorer. We're going to utilize tracing for our diagnostics. And then when we get to the troubleshooting portion of things, which I think we're actually going to do first, we'll utilize the Root Cause Explorer. So there are some other tools you can use, but we want to stress two particular ones. All right, let's see, a couple more slides. So this is the same idea as the iceberg slide that you saw. It's actually is the iceberg slide that you saw, but adding a little bit more to the right-hand side of the screen. So what we're trying to start to bring in here is, as you get deeper into the iceberg and deeper into the stages of figuring out what has gone wrong and why and where and how, what data you need. Once again, for monitoring, you need those logs and metrics and traces, and you can have a subset of one or the other. You can monitor just through logs, you can monitor just through metrics, but having all three is going to give you the best experience for what. And then we're going to utilize the logs and traces, and that's what we'll do in the labs, to start to dig in that where, the why, and the how. On a workflow, on the far right here, what we're showing is once again, it's the depth of understanding of your environment or architecture through the amount of data you're utilizing. So in essence, at the very top, if you're just monitoring, it's very easy to create a simple dashboard that turns green when it's good, red when it's bad. That's not very hard to do. What does get harder to do is, as you want to get deeper and figure out what's causing that alert or that dashboard to turn green or red, digging into the deployment, getting to the cluster level, going a lot deeper and needing to go to the pod level, and then ultimately getting to the root cause. And as mentioned, and as the name implies, Root Cause Explorer will help us with that portion. All right, one more, I think it was one more slide here. And just wanted to show different usages or values of who can benefit from observability. Once again, I feel like we probably know that everybody can benefit from observability, but this slide is meant to prove that, if you will. So what I have here are different personas or teams and how they might value or get value from observability. So for example, on the far left, I have my SREs, my DevOps, those individuals that are responsible for monitoring the health of an application. Why would they want observability? Well, they want to be able to quickly monitor, diagnose, and troubleshoot application health issues. Those on the software engineering side of things, why might observability help them? Well, they're going to want visibility into that software pipeline. And so they can start to collect information about the software pipeline and identify issues with the software delivery process and start to improve quality and delivery of the application. DevSecOps, those people that are focused on security, why do they care about observability? Well, they want to observe the security posture of their applications. And so they can all do so through Sumo Logic. All right. Let me skip through these. There we go. So what we're going to do now is start to dig into Root Cause Explorer. So I'm going to, let's see, I'll go with the slides for a moment or so. I'll probably do a little slide intro, and then we'll get into the app and we'll really go through it together. So what we want to do is now introduce, as it said, metrics and Root Cause Explorer. And so here is Root Cause Explorer, or at least a screenshot of it. And so what it is, as you see here, a graphical interface that you can utilize that is going to start to have the system determine what is normal and what isn't. So for example, we have the middle section of our, in this case, our screen here, showing our events of interest, and we have 4 dots here. What's occurring is the system is utilizing the filters that we've defined or set in place and starting to show us those things that it considers to be abnormal or weird, is another way to put it. It's also going to show us other things, and those things are going to be represented in colors. So what I'm seeing here is there have been 4 errors over the last couple hours. That's a good start. It's showing me a time range for those 4 items. And what I'm going to be able to do, and you'll be able to do shortly as well, is start to look at those items and start to get some understanding of what's occurring and when it's occurring. We have, so as mentioned, it accelerates the troubleshooting. And it's going to show those unusual spikes or that weirdness. Here's a filtering that we're going to be able to utilize so that we can go ahead and specify what data within our account we want to look at. So in our account, and especially in our training account, we have a lot of different sources of data. And so you can start to utilize those filters to look at what's important to you. As mentioned, the colors are going to indicate status of what has occurred. And then we're going to have our events of interest, which are going to be sorted by time or arranged by time, I guess is a better way to say it, and is also going to show drift. So this is going to show 2 items. It's going to show duration and drift by time. Drift is deviation from the norm. So the lower you are on the y-axis, the lower you are to normal. As you get higher, that becomes more abnormal. We have our events of interest by time. So what it's showing here is kind of just taking the events of interest, the graph above, and just kind of flipping it top down or looking at it downward. So it just gives very similar data, but just a different view of it. And then what we're going to start to see are entities. And so these entities are going to start to tell us who or what has occurred. So an entity is a computer name, an IP address, that type of descriptor. But let's go ahead and jump in. This is not the best description. I just want to go in and let's play with it together. I think that's going to be more effective. So what we're going to do is we're going to go ahead and log in together to the system. So let me skip all this. Yeah. So we're going to use Training Plus Analyst account. Yesterday we used Training Plus Admin. So these are going to be Analyst. Let me go ahead and put the credentials in. There we go. So we're going to go to service.sumologic.com. We're going to use the email address of training plus analyst number, and I want you to select a 3-digit number. If you joined us yesterday, you don't have to use the same 3-digit number. In fact, it really just doesn't matter at all. But if you want to, that's fine. The password, different password as well, because this is a different system or different credentials rather, is learning 22 exclamation point. And so these credentials, it's the same system, but as we learned about yesterday with Sumo's configuration of accounts, we're giving you access to the same system, but just a different set of credentials to have you only view analyst material. All right, cool. So Chad's in. Let me go ahead and log in as well. The other thing I need to do is, let me do this right now, is give you the lab guide. So yesterday when we did the labs, Odell brought us into, where do we get the labs from? Like into the help documentation kind of area. For this portion, we have them in a PDF. So what I've done is just attach them in a PDF into the chat. It's loading currently. There we go, just loaded, I think. So go ahead and grab that. Hopefully everybody can access that. So you should have a PDF that looks identical to this. So I'm going to go ahead and log in, and then I'll make sure that we're all together and have everything, all pieces. But I think we should be good. So training plus analyst 224, learning 22 exclamation point. All right, and hopefully you're logged in. What you're logged into, as you probably know, you might have tabs across the screen. This is just because somebody else is logged in. Feel free to close all of these. And so ideally, you would be on a screen that looks like this, logged in with your training account down here. and ready to go. So I think everybody is. I'm going to assume everybody is. Okay, I think we're good. All right, so with our lab guide, lab 0 is purely just logging in. So we did lab 0, so yay. Now to lab 1. What we want to do in lab 1 is show you Root Cause Explorer. So what we have is a scenario, which we're going to go through. But let's go. Let's go through it the way it has it here. So here's the scenario we're going to face or utilize today. We want you to imagine that you're part of Travel Logic. So I had mentioned Sumo Logic Coffee, and I think we're going to use that example later, but for now we're going to use Travel Logic. And what that is a website that helps people book hotels and airfare and things like that. James, I see there's a question. Let me go ahead and allow you to talk. There we go.
I was just wondering, is the Cert Jam PDF that we just downloaded the same as the student lab guide that's on the website? Or they differ?
It should be the same, but we made some changes just a few hours ago, and I don't think the new ones are in that portion. So this in the one in the chat is newer.
Cool enough.
So normally they would be the same, but in this case, yeah. All right. So in this case, we're part of Travel Logic, and what we're going to be doing is, or as an employee of Travel Logic, we want to go ahead and look at various AWS services. We've been hired by Travel Logic. We're DevOps specialists. We know about AWS services, and that's why we've been brought on board. Particularly, we're going to be focused on the AWS service of ELB, Host EC2, and DynamoDB. Those are our specialties. Those are what the customer uses. That's kind of where our lab is going to be pointing you to. So we're going to look at those specifically. And with our story here, the Travel Logic app is facing unusual latency. So what we need to do is figure out, or not figure out, this is more of a tour, but what's going on. So we're being told that there's some latency, there's some issues with the environment, somewhat related to DynamoDB and the load balancer and EC2. Well, now let's go ahead and see it. Let's observe it. So we're going to use Sumo Logic for that. So what we're going to do here, and I'm going to get my PDF out of the way, is go into plus new and go to Explore. Now, we're not going directly to Root Cause Explorer yet, although the slide said we were, but we're going to go through another portion of the system. So as we're going through, I'll just give you the tour. So we're going to go to plus new and go to Explore. When we do, we're put in the Sumo Logic Explorer view. And what the Explorer view is going to allow us to do is view data that's been, basically the data has been pumped into Sumo Logic, and we have the ability to start to look at it through the lens of Sumo Logic, similar to how an app might work. Now, by default, you might not have any data up here, and that's okay. It's set to a Kubernetes view, which is not something we want to deal with right now. What I do want you to do, though, is go to Explore By and select AWS Observability. So Explore By AWS Observability. When you do, you should now be viewing AWS information. And so what we're starting to see here is our AWS information by account. So imagine we have multiple accounts. We have a production account, we have a staging account, we have a development account, et cetera, et cetera. That's what we're starting to see here. And so once again, we're starting to observe what's going on. In this case, for this example, we want to look at the prod data because we want to look at production. And specifically, we want to look at US East 1. And so now I am zooming in, or zooming in, I guess is sufficient, on that region. So now I'm looking specifically at AWS observability or information for my production account, specifically for US East 1. feel free to scroll around here and feel free to poke around. Of course, we're going through on a guided tour, but feel free to click whatever you want. Most everything should work. But what we see here now is information related to our AWS account, specifically our US East 1. So I can see things like, there's so much stuff I can see here. Application load balancer. I'm seeing some errors related to the application load balancer that might come in handy in a few moments. EC2 information. ECS information, load balance, so much information. I also have other dashboards that I can utilize. Although these, these are okay. But I do have some other dashboards, and I do want to start to show you this one of number 2. So in number 1 by default, we get some overview information. What we want to do, though, is we want to go down to the dashboards and select number 2, which is the AWS region events of interest. Now, the events of interest screen is showing us, it's almost like a, how to describe it? It's almost like a mini version of root cause explorer. It shows some of that same events or things that have occurred. It shows the time and the duration, but it doesn't have much filtering, although it has a little filtering up here. It doesn't have as many options. So it's a similar view. What I do want you to do is to go to the 3 dots up here, and go to Open in Root Cause Explorer. And so ultimately, we're in Root Cause Explorer. This filtering is really weird. Let's see. Let me try. It brought over some of the filters that I didn't really want it to bring over, which I thought it was helping me, but now my screen just froze. All right, having a little issue here, but there we go. What I have here is actually I have way too much data is the problem. What I really want is, as it's set up here, and hopefully this is more similar to the way yours looks. But ultimately, what we can do here is we can go to new root cause. Oh, let me do this again. I want to go to new root cause. And for the filters, let's see, what is it? Trying to figure out why it may have worked for you. So if it's just me, my computer being a little weird, let me know. Let me try this one more time through the lab guide. So we go to prod, we go to US East 1, we select the region of events of interest, which you should see there. And then what we want to do is we want to open that in RCE in these dots. And what it should bring in I don't know why mine's being so sluggish. Yesterday, Odell had issues with collectors, and today I have with here, my machine. Oh, here we go. There it goes. Okay, so what we see in here, is events. So we start to see errors. We start to see bottlenecks. We start to see when they occurred. We start to see what occurred prior to them. So here, for example, as I mouse over these, I get information about them. This error right here, it's a Lambda error. It's related to US East 1, which I kind of know due to my filtering. I see the metric that's an issue, which is the errors, which is kind of related to why it is an error or caught as an error. I see the drift, which is showing me that over the past 10 minutes, or that 10-minute period rather, from 1020 to 1030, it was at almost 400%, which is abnormal, which is high. And so the system's letting us know that's weird, that something's not quite right. Let's see. We should also be able to see 500 errors. Where are they? Should show up around here. Well, for any of them, it wants us to look at a specific ALB 5XX error, but 500 error, excuse me, but that's okay. But the idea is that we can mouse over these and we can start to view the fact that they are abnormal. We can also go ahead and click on these. So what I can do is I can click on, for example, this error. And on the right-hand side of the screen, I'm going to get more context about it. I'm going to see those details. As I mentioned earlier, it's a Lambda resource error, but I start to get some tags. I start to get some metrics and some graphing of these metrics. So here, what I'm starting to see is what's occurred yesterday, time shift 1 day ago, what's occurred a week ago. So it's starting to give me some context. When I look at the entities, I start to see these grouped together, and I think we'll get into this in a moment with the lab, but I start to see those. Now, what I want to show, or what I want to try to show here is the example that, let me see if I can just set it up real quick. Where did I find the prod? I think I'm having a little issue with my data set here, because what I should be finding are some 500 errors, and I actually see them. Let's see, maybe we can do this together. So I see them if I go to US East 1, back to this. So what I'm trying to get to or show you is these errors over here. There's one of them. There they are. Okay. So if I don't get them this time, it's not, well, we can continue. I don't want to tie up too much more time with this. All right, so what I see here is 500 error. And so this is what I was trying to show. And so the way I did it is looking specifically for the application ELB data. But basically what I was doing is using my filtering. And so what the system is showing me is here, this error. I see it's 500 errors. So this is an increase in 500 errors. And I start to see the abnormality here. This is probably the best example of what I was trying to show, or what the system's showing me. Excuse me, the system's doing the work for me. What it's showing me here is the count for today. So how many errors did we have today? How many ELB 500 errors did we have today? How many ELB 500 errors did we have yesterday? And how many ELB 500 errors did we have 7 days ago? And what I'm seeing here on this portion of the graph is I'm seeing there were errors yesterday, there were errors today, and there were errors a week ago. But they were pretty low in the amount of errors. There's not really any big spikes here. What I see here, though, is a spike that occurred at 5:30 a.m. with a bunch of errors. So the system's letting me know, hey, this is kind of strange. You have a lot more errors than normal. Errors themselves are kind of weird or abnormal, but you have a lot of them. And that's what we're starting to get from right here. And now what I want to do, or will try to get us to do, is start to figure out why these are occurring. And what we should have, I should have a bottleneck up here. That's what's confusing me, that I don't have that. You can see it in the chart here, and maybe I'll just use the lab guide to start to kind of walk through it with you. But what we're trying to point out is the fact that we have the error. And then we can start to look at things that occurred prior to that error. And so we can start to see a bottleneck. Let me go ahead and add my DynamoDB. That should bring it in. There it goes. All right. So what I did is, for my namespace, I'm making sure to use ELB and DynamoDB. And I'm not sure why those didn't come in automatically when I first did that. It should have. It did earlier today. But anyhow, what we see here, once again, is we see the errors. And then I see prior to that is a bottleneck. And the system's letting us know, hey, these occurred during the same time. They might be related, they might not. But we can start to see some correlation here, that these 500 errors occurred, and prior to that, there was a bottleneck. Now, more specifically, we can see why that bottleneck occurred. We see it's a DynamoDB bottleneck, but we can see specifically what the bottleneck was related to, in this case, write throttle events. And so we can start to see that somebody or something may have started to limit the amount of, I didn't mean to turn those all on and off. Somebody or something is starting to limit the amount of, or not limit, the amount of write throttle events. Sorry, getting all tongue-tied there. All right, so let me go back to the lab. Let's see what we can salvage from here, because there's good stuff in that lab. All right. So what I was trying to show, or what we're seeing here, is the idea, as it shows here, that possibly there was some DynamoDB throttling, and as a result of the database getting throttled, it resulted in some errors related to those rethrottle events. Now, the entities tab I mentioned and want to take a look at it now. So in my example here, when I'm looking at the error, I can go ahead and look at the entities. And so these entities are starting to show me the relevant, well, entities or environments, as well as some graphical information even further, if there is some. Depends. Some of these have them, some of them don't. All right, and what I want to do right here, my screen is a little wide there, is I want to go ahead and open so using this open in right here, I want to go ahead and open that. Wait, let me see here. There we go. Open in entity dashboard. There it is. And now we're starting to look at that DynamoDB and starting to look at the write capacity. And once again, more in depth, going deeper in that iceberg of what's occurred, where it occurred, how and why it occurred. And so that's what all this is about, is just going deeper and deeper into the system and doing it through graphical interface, not really having to type too much, which is always helpful. So now that I'm in here and I'm starting to look at the DynamoDB, I can go even deeper and I can start to look at the events. So as I was trying to point out earlier, there's many different dashboards. And so we have the ability to select one. In this case, we want to look at the events. The reason we want to look at the events is we want to start to try and figure out why or what has caused that, that DynamoDB throttling to occur. It didn't just happen, as we saw everything was cool yesterday, everything was fine a week before, but something fairly recently has happened that has impacted the system negatively. And so that's what we're trying to look for right now, essentially. And not look for, but use the system identify. What we see here in this view are errors. So we see some errors have occurred. That's good to find out. We see some users that have done things. So over time, what has occurred? Table creation, table has been updated. That might be relevant. And we're starting to see some of that description here. What we want to do now is we want to scroll down to the errors. And I want to go ahead and open these in search. And I'm hoping this works. What I want to do is I want to start to look at our logs. Remember, with the observability solution, we have not multi-tenancy, but that multi-pronged approach of logs, metrics, and traces. I want to go ahead and use my logs here. So what I'm trying to do here, if all goes well, and a little nervous about it, but I'm trying to figure out what has occurred to impact the throttling of events. So I'm looking at my aggregation here first, but to look at the raw messages, I can go ahead and select messages. And so what I want to see, I'm not seeing it in here. That's too bad. I think it was working this morning. Let me go ahead and bump this time just a little bit longer or wider. Let's see, did that do anything? Now, I didn't get really what I wanted to show. What we were looking for as it shows in the lab, and I apologize for this. Yeah, I do apologize. But what we were hoping to see is the updating of the table done by an individual called Mike Mann. And the idea is essentially that he updated the table incorrectly. And so he incorrectly did some provisioning and what he thought was going to be some optimization. And so as a result, doing some provisioning of IOPS, it caused throttling and resulted in the outage. And so that's what I was hoping to show you. I know you didn't get that picture, but hopefully what you did get is the idea of observability with being able to utilize this upper level view and start to dig down into those areas that are interesting. And all through, once again, the GUI, which is nice. So feel free to poke around in here, play around. This data, well, it doesn't show the exact story I wanted to. Other than that, it is, it is functioning and working. So feel free to utilize that in any way that you'd like to. All right, let me see where we're back with the labs. Let's see. So we kind of stumbled through that last one. All right, let's get, let me see here. I'm probably gonna do a couple slides and then we'll get back into the labs for tracing. Let me just make sure. This is worth pointing out kind of quickly, but within RCE or Root Cause Explorer, it's relying or utilizing various troubleshooting concepts, as we call them. And I thought it was important just to describe those of how or what analytics it's using to determine what should be looked at. So abnormal spikes are going to be important. Those are going to be, as it shows here, an indication of an underlying problem. So looking for those abnormal spikes, digging into when they occur, certainly a good suggestion towards troubleshooting. Context and correlation. So starting to look at those spikes in relation to something else. When did it happen? What else occurred during that period that it was happening? That's going to be helpful. Connection. So starting to look at various resources. It happened in one resource. Did it happen in another? Are those two related? Does it help lead to the cause? Earlier spikes. So as things start to occur, typically they're going to occur prior to the root cause of the issue. So usually something's going to happen and then you're going to have spikes. And so those are ones that are probably going to be more relevant. Dig into the logs. Unfortunately, our log exercise didn't really get us as deep as we wanted to, but what we were trying to show is the ability to look at those logs to see who was doing something, what were they doing, and how it related to the overall scenario of what had occurred. And then golden signals. Golden signals are it's actually a Google thing, but those are those groupings that we had of bottleneck and error. Those are the golden signals, essentially, that are, as it says here, help to organize the root cause, essentially to classify different events, give them a label, if you will, and then you can start to look at those labels. So, all right, let's see, time-wise, I think we're pretty good. I'm going to skip over the discussion portion of that. Oops, actually, a little bit too fast, because I do want to start to talk about tracing now. All right. So traces are going to be an essential pillar of that, the observability solution, because it's going to help provide context for other components of observability. So for an instance, we could analyze a trace that's associated or going to identify the most valuable metrics just based on what we need to look at, or it could be the logs that we're trying to utilize. So traces allow us to use a few different methods here. So traditionally, metrics have been used in classic monitoring. But as mentioned earlier, that's only going to look for a known failure condition of the application. Observability, as described a few times now, requires you to completely understand the application so that you can identify, troubleshoot, and fix failures or any conditions that might occur related to the application and its health. And to gain the insights from the collected data, it's not just about collecting and analyzing metrics and logs, you need more than that. When used optimally, logs and metrics might be sufficient for understanding, but they aren't going to be sufficient to understand the lifetime of a request as it traverses multiple systems. And this is where distributed tracing, or we're just going to refer to it as tracing, is a technique that's going to address the problem of bringing visibility into the lifetime of a request across several systems. Troubleshooting problems real-time and distributed dynamic cloud and microservice environments is very difficult. And transaction traces is going to make this a lot easier by letting us see the details about what exactly is happening and how it impacts our users. So what is tracing? Tracing is going to be a significant technique that's used in monitoring modern applications that use distributed microservices architecture. And that transaction trace is going to give us a detailed snapshot of a single transaction lifespan across our application environment. A trace is going to follow the course of a user's request or a system call from its source to its ultimate destination. We're going to need to utilize, or we are going to utilize, transaction tracing to profile and monitor microservice-based apps and architecture, to locate failures, to improve performance. In fact, log metrics and traces serve their own unique purpose and are complementary. In unison, they provide maximum visibility into the behavior of the distributed systems. And so that's why there's three pillars of the observability system. All right. Now, tracing is going to play a crucial role in tracking transactions of an app on a microservices-based architecture. And so even a simple three-tier application, and we're going to use our Sumo Logic Coffee example, might require going through a load balancer, going through a couple servers and a database. And so observability means being able to ask any question you need about your application and how customers are interacting with it. And so using the Sumo query language, we can go ahead and do this with logs and traces. And this is also a large differentiator because no other tool really provides the ability to start to slice and dice that span data using a query language like Sumo's. Now, when is tracing the best option? And I like this visual of just to simply explain tracing. I feel like the other slide probably you understand it, but here's a perfect example and one we're about to use just differently. When you get a package sent to you, it goes through various hops. So a package just doesn't go from you, from a vendor to you. There's steps along the way. As we show here, it gets shipped. It goes to a FedEx location. It goes to another location as it slowly gets to the right place. And so what tracing allows you to do is, in a similar example, start to see where things occurred. Where did they get hung up? If this spent a long time in Pennsylvania, that's interesting. If it spent a long time in Ohio, that might also be interesting. Might not be as well, but it's going to help us start to figure out what's occurred and start to possibly solve the problem. So if we start to see, for example, a bunch of different traces or transactions, we order a bunch of different products, excuse me, from a vendor, and we see they all end up getting delayed in Ohio, well, that might be relevant to something. Maybe we can, work with FedEx to figure out why our package is getting delayed there and what's occurring. And so similar idea, you have the user interface. They're going to go through a bunch of steps to log in, to place the order, et cetera. And so tracing is going to allow you to see, oh, they went here, then they went there, then they went there, versus somebody else that took a different route to get to possibly the same place or a different place. So that's I think a good illustrative example of tracing, that idea of just tracing or tracking a package. All right, so now what I want to do is, let's see, time-wise. Let's see, let's keep going here. So what I want to do is introduce the coffee app, and I kind of did this already with the idea of Sumo Logic Coffee, where our goal is to deliver a hot, fast cup of coffee. We have locations around the world, and so how is technology, Sumo Logic, observability going to help us with a cup of coffee? Well, let's see. So here's an example. This is what a successful order at Sumo Logic Coffee looks like. And so, as occurs when you place an order for a cup of coffee, these are steps. You're going to place the order through the app. The order is going to post to the barista. So the barista is going to get that order, and then he or she is going to start to work on the coffee machine. And the coffee machine itself is really doing a lot of the work, or most of the work. The coffee is going to take those beans that it has and check that it has the right level for beans, or the right level for ingredients, and grind them. Check that water level, make sure it has enough water, add it, do its magic, and then you have the cup of coffee. Now that coffee is going to be ready for the customer, but the customer needs to pay for that order. The credit card needs to be approved, and then the customer picks up the order. And so in those regards, each step along this process is like a microservice. And so several microservices are going to be used. Things that are going to require user login, order registration, water service, coffee service, payment service. Those are all various microservices. And so in the case of a failure, it's going to be difficult to fully understand the actual cause of the outage due to the complicated and dynamic nature of a microservices-based architecture. Now, fortunately, tracing is going to help us with that. And so here's kind of another view of that same idea of how those applications are going to be split across those different microservices. So here we have Abel, who is our coffee lover. He loves coffee, and he uses our app to order the coffee. So it goes to the app and places an order, and the order gets processed, and the barista starts to turn on that machine and create that cup of coffee. Now, when that occurs, there's really two things going on. There's the machine side of things, which is going to be in charge of creating the cup of coffee, brewing it, checking the ingredients, delivering it, making sure it's hot, it's good, it's high quality coffee. But there's the payment side of things. We don't give cups of coffee away for free. We charge for them. And so there's the payment system that needs to kick in. When Abel orders his coffee, what type of coffee was it? An espresso and a cappuccino are two different prices. So the system needs to look at the SQL records to see pricing. It needs to invoke a calculator service to start to figure out, if you got 2 cups of coffee or 3, it's different prices, and that function needs to occur. Now, how does tracing work in this idea or in this scenario. So what we have is a simple client and barista scenario. Abel is going to order the coffee. The barista is going to get that order. He or she are going to prepare that order and deliver the cup of coffee to the client. So Abel is going to wait for some time for his cup of coffee, and then it's going to be delivered. Now, here's where we're going to get a little bit deeper on it. It's going to be important for us from an observability standpoint, to understand what's taking place, because Abel's going to order his cup of coffee, but there's going to be time that's going to occur. And so that time is going to start to be described as a span. And so what we have here is the idea of an observer and our spans. When this order takes place, we need an outside observer, as we call it, to gather information about the interactions that's occurring between the client and the barista. And so this observer is going to look at both interactions holistically and gain insight into, or by looking at the complete picture. So for example, we have our client barista, as we just discussed or described, excuse me. And they are going to report the time that data is sent back and forth. And so what we're starting to see is the observer is starting to keep track of when things occurred. At time 0, Abel places his order for the cup of coffee. At time 1, the barista is receiving that order for a cup of coffee. At time 2, barista is preparing and delivering the cup of coffee. And then time 3, what we see here is the idea that the coffee has now been received by Abel. So it's gone from the barista to the client. Sumo Logic's tracing is going to allow us to look at these events and start to understand when they occurred. And it's going to be done by breaking them into spans. So what we start to see here is now this order is starting to get a little more complicated. Not more complicated, excuse me. It's a simple order, but we're starting to get more granular about what data we're getting from it. We're going from just Abel placed an order for a cup of coffee to Abel placed the order for a cup of coffee at a specific time. Then that time, the barista got the order. Then the order is processed by the barista. And so these different times or groupings are broken into what we call spans. And so what we're going to start to look at are those spans and start to see, are some of those spans longer than another? We would expect the span from the client sending a cup of coffee to the barista receiving the coffee to be pretty quick. Order comes in, that barista should grab that order and place it and start making that cup of the coffee. So it should be probably a few seconds. If we look in our tracing and we start to see that that process is taking a few minutes, well, then something's wrong. And then we can start to go down that kind of rabbit hole, if you will. And we're going to do that with our labs shortly. All right, I'm going to go through one more portion here, which is service maps, and then we'll take a break. So break in about very quickly, about three minutes. So service maps, and we're going to use these in a moment, as I say right here, is going to provide a high-level view of application environment. So what the service map is going to give us is a constantly updating diagram or a map of our services and the interactions that they're going to have with each other. Each service is going to be shown as a bubble, and an arrow is going to connect the two. So actually, let me just show it. So the value this service map is starting to bring is it's going to show us the services that depend on one another. And so, for example, here we're starting to see our coffee bar app, which is our coffee app. We're starting to see the various services, the coffee bar, the coffee machine. As we go further to the left here, we see the coffee machine is made up or consists of the machine service. The machine service consists of the water service and the coffee service. On the right-hand side of the screen, we see the coffee bar and the cash desk, and we see the SQL account, the calculator service, all these different services or aspects that need to work with one another. And so we get this view into the system. Why don't we go ahead and pause here? What we're going to do next is actually start to look at some service maps. We'll actually go into the system. It's missing a slide here. There we go. So we'll actually do this when we get back. So let's take a break now. Let's take a let's do a 7-minute break to get us back at 15. So 7-minute timer. There we go. So 7 minutes, come back. We'll do some more labs, and then we'll continue and take that exam. So thank you, everybody. I'm gonna put myself on mute. I need to grab a beverage. But if there's any other questions, go ahead and put them in the chat, and I can address them during that break as well. So thanks all. See you in a few moments.
Oh, I've been on mute. Mr. Chad, you there, Chad? Testing. 1, 2, 3. Testing.
All right, everyone, welcome back. Hopefully a good little break there. Let's go ahead and continue. So I have a few more slides here and then we'll get into the labs. I'm trying to really drive us through the labs because they're much more fun for both of us, but let's just do a few more slides here. So I started to talk about service maps, and here's a visualization, and you'll experience it in a few moments. So you can go to the plus new service map, but we're going to do it as a lab in a few minutes. So just hang out for a minute. So what we're showing with that service map, once again, the idea of a high level overview, blue is normal or no color is normal, reds are anomalies. As you see here, you'll be able to mouse over them to get a better understanding of what's occurring. And there's going to be a variety of different settings that you can use to set or configure the anomaly detection. All right, now traces we want to talk about next. And so as mentioned before the break, essentially like when you trace or track a package, is that same idea. So what I see here on this screen, and we'll do this in a moment as well with the labs, so don't do new traces yet, although you can if you want, is essentially I see a bunch of different orders here. So if we're talking about our coffee service or coffee company, I see trace IDs, which are essentially transaction IDs. I see the root service, in this case, the coffee lever. I see when these started. So this data is a little bit old, but I see the date or the time that the order was initiated. I see the duration. So this is showing me how long each order took. Remember, we want to deliver a fast cup of coffee, so speed is important. I see, although this column is kind of blurred, number of spans, essentially, this is showing me. And I start to see a duration breakdown in a graphical view. Now, these colors are going to be associated to something, and we'll see those in a few moments. So here, for example, at the top of the screen is a successful order. It's represented by the fact that it has a 200. 200 means, in this case, means good or successful. And when I see this order, I see in the top bar here the various services, and it's a little hard to see here, but I see in the green it's the cash desk, so that payment service, I guess. I see the coffee bar, which is responsible for some of the ordering process. I see the coffee machine, which is responsible for actually producing the cup of coffee, and so on and so forth. And then down below that, I start to see the spans or the traces. Well, these are specifically spans of when they occurred, how long they occurred, comparison of just a visual comparison of the top line representing the whole order, the bottom ones representing separate processes or steps or services. Now, conversely, here's what a bad order looks like. In this case, it's a 503, and we'll look at various status codes in a few moments. That'll be part of the lab. But what I see here is red, specifically red on the horizontal lines. And what red is indicating is that there's an error. Red is bad. What I'm looking at here is specifically the lowest level that has red. In this case, this little blue box at the very bottom. That's indicating to me that is where the error is. And what we're going to do shortly is start to look at that error and figure out what it means and diagnose it. So as mentioned, just once again, here's a successful order at Sumo Logic Coffee. It's hitting the cash desk, the coffee bar, the machine service. It's all good. There's no red. And so that's what we want. All right. Let's do, I think we can go to the lab. Yeah, let's do the lab guide now. So what we want to do now is jump back into our lab guide. And we want to do lab number 2, tracing in Sumo Logic Coffee. And so what we're going to do is walk through the steps as described. So first, we're going to introduce the service, not introduce, I already introduced it, but we're going to use the service map. So what we're going to do, and let me just reconfigure my screen size here. It's good enough, I guess. So what I'm going to do is go back into Sumo Logic. I'm going to go to plus new, and I'm going to go to service map. Now, by default, when I run the service map, it's going to do a service map for all the applications in my environment, which is good. I mean, it should do that. But in this case, we don't want to look at some of this stuff on the left. This is just lab data for other examples. This is for our banking scenario. So what I want to do, or what I can do here, is I can start to use my filters and say, only show me the coffee bar app, because that's all I care about. And so by selecting that, it starts to now zoom in more specifically on just the coffee bar app. And what we're seeing here is the various services. So here's that coffee machine. Here's that machine service. Here it extends into the coffee and the water service with coffee and water service here. I can go ahead and mouse on these. So here I see why there's an error, or why it's red, not necessarily an error, why there's an anomaly due to latency. If I click on it, I start to get some graphical representation of what's going on as well. So here I'm starting to see that latency visually, which is all just helpful to get a better picture of what's taking place. Now, what I want to do next is I want to go ahead and select one of the services that has an anomaly, either the coffee service or the water service. I'm going to encourage us to all use the coffee service just because it's a little easier to show, but you can use either one. So I'm going to click on the coffee service, and now I'm getting some information once again about the latency, but I don't really know what's going on here, what's wrong. What I want to do here is I want to, and as it shows in the lab, is I want to go ahead and open in, and I want to select traces. And by doing so, what I'm essentially doing is viewing traces with a filter. So it's essentially the same thing as if I had gone to plus new and traces. Similar as to the way earlier when we were looking at or trying to look at that DynamoDB and ELB issue data, we looked at the observability tab, the Explore tab more specifically. And then we opened in the events of interest and got into Root Cause Explorer. Similar idea where we're going to the service map and we're filtering down to some degree. So now what I'm looking at here, as mentioned, are the trace IDs, so those various transactions, when they started. I see the duration. So once again, speed is going to be important. I see a duration breakdown. So this is giving me graphically the entire order process, as well as each step and how long that's taken, essentially the spans. And I also see number of errors. So this is letting me know that there's errors. Now, the goal here is to figure out what is the error. What is causing the issue with the coffee service? Why are we getting these errors? All I know right now is it's related to the coffee service, but that's not very helpful. So how do we do so? What we're going to do is we're going to select one of these traces. It does not matter. It should not matter which one you select. I'm going to pick that one. And what you should see now is the transaction, the services that were utilized, and a breakdown of those services below. And what you ultimately should see, or what I want you to see, is the lowest line with red. So here, all these lines have horizontal red lines, but we want to go to the lowest level, which in this case is this brown, or I guess it's brown color. If you had selected the water service, the water line would be red. But since we selected the coffee service is red. Now, what's happened here? Well, let's go ahead and click on it. We can filter on the error spans only if you want to. It doesn't really help that much. Kind of just grays everything else out. So it's kind of helpful. But what we want to do is we want to click on that guy right there. So you want to click on the coffee service, forget beans. And when we do, what we should get is this ability to start to look at the span. We actually have the ability to look at our logs, either through the span ID or the trace ID. And there's a difference of, well, obviously there's a difference. The span ID is going to show us just for that little span, just for that red horizontal line, where the trace ID is going to show us for the entire transaction. Now, in this example, I'm just going to use the span ID. I think that's going to be illustrative enough. Feel free to use the trace ID. It's just much more verbose. So let's go ahead and look at the span ID and try and figure out what has gone wrong and why our order has an error. When I click on the trace, the span ID to open the logs, it then opens the logs for me. And what I see here is a log message, and I see what's occurred. I'm going to read this from bottom to the top because these are in sequential order, and I want to look at the oldest message. So the message is info received order for coffee grains. Remember, somebody placed an order for coffee. So the system is saying, okay, I need this many grains of coffee. What happened? Uh-oh, error, lack of coffee grains. So what happened here is there was not enough beans or grains in the machine to produce the cup of coffee. And that's kind of ta-da. That's the issue. That was the problem here. Conversely, I'll do this quickly, not too quickly, but if I go back to my service map and I go to water service, so now I'm looking at the water service. If I do basically the same function, I don't know why that's not, that should be blue. Let me try this one more time. It's weird, that shouldn't show up here. Let's see. All right, no, so these are actually working. So this is a water order, that water one that was successful. And so here we've received order for the water, and there's water in the machine. So going back to, and I shouldn't have gone to that water example, sorry, but going back to the example with the coffee. So what we see here, what we were supposed to see is the idea that the system did not have enough coffee in it. And so then what do we do then to resolve that going forward? Well, then we could go ahead and maybe we just create a bigger water reservoir for or coffee hopper for our coffee machine, or different ways to approach it. But now we're able to see something as simple as not enough ingredients through through technology, through computers, which is kind of cool. So that's what we were trying to show there. I hope you were able to see that. I think everybody was. All right, so that's going to go ahead and conclude that lab. So let's see, where are we at now? Not where are we? I know where we're at, but let's see. Let's go back to the deck. Let's see. So we did some of this already. We did the service map. We did the traces. So we did all that. Let's talk about. Let's talk about, yeah, this is, well, yeah, we absolutely should talk about this, is observability and logs. So completing that multi-tenancy, or not multi-tenancy, excuse me, column configuration of logs, metrics, and traces. We looked at traces, we've looked at metrics. Now we're going to talk about logs a little bit. So logs in Sumo Logic, well, that's an example of probably not the most effective slide here, but what we're showing here is just the idea that there are logs in Sumo Logic. And so a log, as a reminder, I hope everybody knows this, you might not actually, but a log is going to be a system generated string of text showing when an event happened to describe an event. So a log message is going to contain log data. The details of the log data are going to have the information about the event, what resource it accessed, who accessed it, a time, things like that. And the collection of those logs is done through the process called collection, which we saw yesterday. So getting them into Sumo Logic, you already know how to do. So what we want to do now is a log activity around, a lab activity around logs, excuse me, tongue twister there. So what we want to do here, a similar example to what we were looking at earlier, but essentially an idea where we have an outage in US East 1 for the last 24 hours, and we want to go ahead and start to utilize the logs to start to figure out what has occurred and use that observability solution to observe what's going on. And so that's what we're going to do now in the lab guide. So what we're going to do here is going to grab our lab guide. Where's my lab guide? There's my lab guide. And go through lab number 3. So with lab number 3, the scenario here is we're an SRE. We're involved or related to the coffee app, US East 1, last 24 hours. And there's been an alert on the Lambda server. So we want to figure out what the alert is related to. So let's go ahead and go into Sumo. So we're going to go into Sumo. We're going to go do a new explore. And we're going to want to go to that AWS observability view, which should be set to if you set it earlier. If not, go ahead and just select from the down arrow here and select AWS observability. All right. Once you have that, more specifically, go to prod and US East 1. And as we saw earlier, we're getting now AWS information. Now, what we want to do here is we want to go to the Lambda panel. So we want to specifically select AWS Lambda down here because we don't want to look at everything related to US East 1. We want to look just at Lambda. So we're going to select it. And now we're going to start to get data or dashboards, kind of however we want to refer to it as, an understanding of our system. So here is information about our Lambda calls, the services that are using Lambda. This performance will load in a second. But what we're going to want to start to look at is these errors down here. And so what we want you to do is scroll down and notice that there's a lot of errors. Specifically, what we want you to do is notice that there's a lot of database authentication errors, specifically related to the get billing info function. So what I want to do here, just to do a little sorting or filtering, is I want to copy that function name of get_billing_info and put it in the function name. I can also just search for it, but pasting it is probably easier. And so I just want to filter on the get billing info because that's where the errors seem to be. And so let's dig into them. So I've now applied that filter. And what I should start to see in here is this most frequent function operations. And what I'm seeing are those functions that have been called. But what I want to look at here is the update function configuration. This only happened once, but I want to take a look at it. So what I want to do is I want to go to this box here, this most frequent function operations, click on it, or click on the three dots, excuse me, and select open in search. And when I do, that's now going to take my query and bring it into my log environment, my search query language. I see all those here, but I want to go to the messages because the messages is going to allow me to actually here use the field browser, which we introduced yesterday, or hopefully you've seen before, but use the field browser to start to apply a filter. The filter we want to look at or utilize is that of event name. And by clicking on it, we can go ahead and specify, just show us the update function configuration information. I don't care about those other events. I only want to look at this one. So I'm just using my filtering to zoom in on what I want to see. And what I should see here now is the idea, or not the idea, excuse me, but the individual of Mark Smith is the individual who has made a change to this configuration. So he has caused the issue related to the update function configuration errors. And so what we would then want to do is probably, contact his manager, contact him and try to figure out what he has done, why he did it, and why that might have caused a problem. All right, cool. Let's see. Just seeing if we could probably go straight into the next lab. Let me see if we need to do the slides for that. No, let's just jump into the next portion here. Yeah, let's do lab 4 as well. We'll be getting done a little bit earlier, but that's not a problem. So let's do lab 4 right now. So lab 4 is continuing that idea of working with logs. And so what we're going to do here, and you might have done this in some of the other classes, not this specific one, but some of this idea you may have seen, but the idea of looking at the data, specifying it, and then using the log environment to filter what you need. So this query you might have seen in Search Mastery, but it's an important one. It's really worth showing again as a reminder. So what I want to do is I want to go ahead and grab this query that's in step 1, and I'm going to paste it in to a new log search. And sorry, didn't hit start yet. So when I hit start, and it says to do last for 60 minutes, it really doesn't matter. We're just trying to show the data, not really a specific time range, or so any time range is fine. But as a reminder, I start to see the aggregation of my data. And so the system is allowing us to take data, utilize the parsing of that data, utilize those fields that exist within that data, and then report on those fields. So what we're doing here is we're we're looking at, or can look at, the specific messages that make up all the logs. Once again, nothing crazy here, just we wanted to show you this. Some people that have taken this course may have not taken things like search mastery, so this might be new to them, but for you guys it shouldn't be, but either way, it's worth repeating. As a reminder, also, when we're using AWS data, the data is automatically partitioned for us. Not partitioned for us, field extracted for us. So what I'm trying to do here is show that when I go to my CloudTrail data, I have all these fields existing in the field browser. I have a field called AWS region. And so I can go ahead and count by that AWS region because the system knows that that field exists. Once again, a little bit more query language than maybe observability related, but we want to give you all the pieces to look at everything you need. So wanted to show that. The log reduce operator, this is also something we went over the other day. I don't really like the example we have in here. Actually, I take that back. The example we have in step 4 is better, and it's very similar to the one we showed the other day as well. This is going to be the log reduce operator. And once again, just more tools to get you into your data. And so let's go ahead and just run through this again as a reminder. So log reduce allows us to take our logs, look at them for a period of time, and apply that log reduce, which is going to look at those logs and group them into categories or classifications, essentially pattern matching, and show us when those occurred and how frequently, or the occurrence of them. So what I'm starting to see here is over the last 15 minutes with my snort logs, I'm starting to see these different classifications grouped together. So here I see an information leak. Here I see a web application attack. And so now using my logs, I'm able to get some understanding of what might have taken place and when it occurred as well. Something else you can do here is, for example, and I'm going to look for a count that's smaller just to illustrate it better, is I can look at that specific log message. So now I'm looking at a specific log message, in this case, a network scan. And now I can use the surrounding messages to start to look at a period of time surrounding this message. So this thing occurred at 5:24. 5:24 with 28 seconds. Show me all those things that occurred before this and all those things that occurred after it. And it's going to also start to reveal that picture. So here I see detection of network scan. Prior to that, I see some other stuff. This other stuff might be helpful in my understanding of what's taking place. All right, and then finally, yeah, we really did this. Let's finish this up. The log compare operator. I'm assuming you have seen this, so I shouldn't. This feature is pretty cool as well. This log compare operator is going to allow us to do a time shift to a different time period. So let me show the example because that explanation was a little weird as well. In this case, I'm going to look at the last 60 minutes. And I'm looking at my CloudTrail data. So my system is going to group those messages in patterns like the log reduce just did. But it's going to take it a step further. It's going to do a time shift automatically, specifically at 24 hours. So what's occurring is it's looking at data for today from about 4:30 to 5:30 local time. It's going to yesterday from 4:30 to 5:30 local time and looking at data, specifically the CloudTrail data, and it's grouping those together using those patterns. And it's starting to show us the difference in those occurrences. So what it's showing us here is that today we had 5% less patterns that match this format. Conversely, we had 21% more of this pattern. And knowing that might be relevant. Not might be relevant, could be quite relevant and quite helpful, because it's usually important for you or somebody to understand this happened then, this is happening now more frequently, and that might be good or bad. And that insight is quite important. All right. And then I'm going to skip a little portion of the lab here. Let's see, what should I show next? Let me go back to my slide. I think, let's see. So we did the AWS, we found the culprit. Let's see, this I don't really need to do, working with logs. So we showed this, the field browser. Let's see. Yeah, let's wrap it. Oh, so this log explain. This is a doozy to wrap up everything, but let's go ahead and look at this real quickly. And this is the last exercise in the lab guide, is the idea of log explain. And what log explain lets you do is it's going to compare, as it says in the lab, sets of structured logs based on the events that we're interested in. So what we get to do is we can specify an event of interest, and that's going to be called or classified as an event condition. And then we can compare it to another event of interest, which would be essentially the against. So we're looking at things that occurred as the event, and then things that occurred against it, which would be the against condition. So let me show the example here, because that, once again, that explanation was a little rough. The idea, though, is we're going to look at that CloudTrail data. Oop. That CloudTrail data. We're going to do a whole bunch of field filtering and descriptions here, although we don't really need to do these JSON fields since the data actually does it for us automatically. And then we're starting to use the log explain here, which is starting to look at two different groups. One that's considered to be test coverage and one that's considered to be the control. And so we're starting to see the frequency or the relevancy of these occurring in two different areas. By clicking on these links, we can actually start to see the query itself and go down to the granular level of those matches. So we should have 12 values in. Oh, it's still going. We should have 12 of these. Yeah, there we go. We have 12 of them. So we're starting to then be able to see those specific log messages. So just another way to get more granular with data. Log explain is not something you're going to use very frequently. It's something that we were kind of, we wanted to show, but it's not something that pops up that often. But I did want to introduce it. I thought it was important enough to do so. All right, let's wrap this up. Let's get into the exam. We're really at the end of the content, so let's get into the exam. So once again, same process as, yeah, I think everyone here was there yesterday. So the same process with the exam. You're going to want to log out of this account. We don't want you taking the exam as training analyst 543. We want you to take it as, James, Chad, and Arjit. So we want you to get credit for the exam. So make sure you log out of the system and log back in. This exam is also going to be open book. So as with the other ones, you have access to Sumo Logic resources, specifically documentation, which I strongly encourage you to use. The documentation will help you with the exam, as you probably saw yesterday if you took it. Let's see, what else? Let me go ahead and put the link to the the most important thing, the Uber Eats. So as a reminder, once you take that exam, fill out that form and get credit for the Uber Eats. If you have not sent in for the class from yesterday, you can send in together. So if you want to send in 2 certs at the same time, you can. Just up to you. Probably easier to do it that way for us as well, but totally up to you. Other than that, I guess let me just show you. Let's see, do we have any questions? No, I think we're pretty good. So let me just show you Yeah, let me just show you which exam just specifically.
Unlike the other exams, we only get one shot at this one, correct?
No, it
What it
says
tells me.
that, but you get multiple. So
Okay.
yeah, it's I think just misleading. Just period.
Are there
Yeah, so you can take it again.
are there any of the other exams out there that are one shot only?
No, there aren't. That's why yeah, they're not. They're not, period. We used to have a limit of 3 attempts per example. We removed that. So I don't know why it says 1.
It scared me.
Yeah, no, yeah, I'll address it internally.
You scared me when you said it.
Yeah, I'll figure it out what's going on with that.
Well, I
So
started to think,
did you all you guys find the exam? Do I need to show?
I did.
Yeah.
All right, let me just do while I'm here. Might as well just show it. Oh.
Did you really work at Google?
Yeah, I was there for about 6 or 7 years, maybe 5 years. But I like it at Sumo. It's I like the organization. All right, so certification, get certified. And if you already started with the exam, just ignore this or put me on mute, I guess.
I stopped it.
So get certified. And then it's going to be the observability fundamentals exam. So this one right here. Now, let me just see about that. Let's see.
Oh, they dropped the score on this one?
No,
I thought the other ones were 75%.
yes, they did actually. Yes, that is correct. Yes, it's a good call. This you don't have to do as well.
Yeah, I remember that, but I won't remember the first statements when they come up. So
Let's see. Let me just double check that middle answer. Yeah, it lets you take multiple times. All right, so I'm going to put myself on mute. Odell will hang out with you for a little bit. Best of luck on the exam, and hopefully you can join us tomorrow. The administration class, I think, is it's a little better in this class. It's a fun class because we start to send data to Sumo from AWS. So I hope you can join us for that.
didn't we do administration yesterday?
Very good question. This is going to be observability administration.
Oh, okay, gotcha.
Administration yesterday was getting stuff into Sumo. This is now getting the right stuff into Sumo, getting the observability into Sumo. So yeah, different, but yeah, good good observation. All right, so let me go ahead and leave you guys to it.
Sorry, I just got kicked out for some reason. All right, I got a question for you.
Go ahead.
So there is a question, and I couldn't find where to look. They're talking about matching concepts, service map, span, trace, choice query. Where's the article that talks about these?
Give me a second here. I'll bring up the slides. Hold on a second.
Thank you. You're in the Midwest, right, Odell?
Yes, sir.
Is it pretty cold right now?
Raining. We got a storm coming through, rain, and the cold will be here tomorrow. Possibly.
Gonna float away. It's raining so hard.
So your question was specific. Was it pillars of observability? What was the question specifically?
The question says match the concepts to its description. There's trace query, trace, span, service map, and I couldn't find.
Yeah, I think it's, hold on. think it's one of these. It might be this one.
Don't think so. It's just a description of what a service map is, a span is, the trace query. I didn't see a slide on it, and I was looking through the help, and I couldn't find it. Maybe I'll just skip this one.
Let me do a little research, and if I come up with something, I'll check it out. So it's tracing and mapping what tracing is, I think you said?
Yeah, basically, what is trace query? What is trace span? Okay, I got other questions, Odell.
Okay.
Trace query builder. I tried to find the logical operator help page. And it keeps sending me to a trace page in Sumo, and there's no logical operators on there.
Let's try this one. I just searched again, and I found trace query information.
Okay.
Let's see here.
I've seen this page.
Oh, you seen this one already? Okay. All right. So you've seen that one. Nope, that's the app. So
Right. Let's skip that question, Odell.
service map. Let's see here. Here's the service map.
Yep, saw
Okay.
that page.
Okay. Let me see if I can get this. Hold on a second. Let me see here.
Okay, I got a trick question for you.
Go ahead.
I'm on chat as well.
So mine says, how do you navigate to the root cause explorer interface? And two of the answers are correct. New, go to new explore, and then you can go to root cause, which you go to the three little dots, or go new root cause.
And what are the answer options? They both apply?
No, just pick one.
Oh. Oof.
That's why I'm confused.
I would go new root cause. Yeah, that's the way we teach it.
Yeah, the labs tell you go to explore first, go new, and then go to explore. And then from there, over by the time, you click the three dots and you can say open in root cause explorer.
So the advantage of that is that you get the filtering kind of built in because you zoom down to that level where if you go to new root cause explorer, you're just opening up a raw root cause explorer, which I think is what we're trying to teach you to do.
Okay.
But I can't remember. I apologize. And I don't have access to or easy access to the answer key. So put new in root cause. If that's the one that
That's
things you will
correct.
we'll figure it out with
Yeah.
with the testing group. So
Thank you.
but I'll make a note as well to that's too subtle.
All right, Josh. One more, my last question.
Sure.
And I'm about to just say, screw it, hit next. But this one has 6 different concepts that I have to define.
What's
And
the phrasing of the question itself?
match the troubleshooting concept to its purpose.
Okay, I found the question.
And it
Okay.
has like established connections.
Yep.
I'm trying to find the information on that so I can go find it.
Yeah, let me yes, let me show it to you. This will probably help. Oop, I'm gonna do And I think I have an article I can link to as well. Sorry, I didn't realize you weren't just seeing my screen. I was trying to show you something. Uh,
I can get the information from this slide. Thank you.
cool. Good. You're welcome.
Where is established connections? I'll just skip that one. Whatever I have left over. Which one would you say would be essential for strategies for root cause exploration? Would that be the context and correlation?
Oops, sorry about that. What other options do you have left for?
That,
I'm kind of doing the same thing on my exam here.
yeah, I'm stuck. So I said established connections would be identify relationships between resources and services to help identify root cause.
Yep, I would
Um,
agree.
Earlier spikes are closer to the root cause.
Yep,
That's
that's earlier spikes. Yeah.
abnormal spikes would be they provide indications that there are an underlying issue.
Yep, correct.
Exploration of logs and trace data need to be drilled down to find the actual root cause based on previous analysis. I was iffy on that one.
Yeah, that's what I would put.
It's either that or that one's essential strategy for root cause.
No. I'm sorry, I'm so
No.
iffy on these. It's been a while since I've taken this exam.
Oh, I passed it.
All right. Well, cool.
With a 75.
And FYI, no one sees the score, so all the better, but good.
But no, I didn't want to just get the answers. I was trying to help find the answers so I can because I know I'm going to have questions when we're all done with all this, and I'm doing this in real life. How do I find this stuff? So
Yeah, this is helpful feedback. Those answers are just too subtle, and so they shouldn't be. But yeah, the questions you guys had, mostly you, Chad, but there were some others. I'm going to take back to our our team and look at those with the exam. They're just they're too picky or as you saw, just we want to be as fair as possible. So. But glad you passed. So that's, that's I guess most important. But yeah, hopefully you were able to use the documentation for most of it, which you are. So and we have a new documentation system coming out pretty soon. That's going to be much improved.
okay.
So you'll see that in a few months, I think.
All right, and tomorrow is the administration one, correct?
Yep. So that observability administration is the name of it. So that's going over setting up ingestion. So we'll actually take some data, and if you have an AWS account, that helps. We'll take an account, we'll load it with data, send it into Sumo, then see that it shows on the observability Explorer. And so,
Yeah, we don't have AWS, we have Azure.
okay, we'll figure it out. We'll figure it out together tomorrow. We support it. Just that's not the use case, but yeah, I can prepare. I'll take a look ahead of time. So,
Okay.
cool.
All right, gentlemen.
What do
Thank
the
you.
numbers on
Thank
the root cause explorer mean? Those instances?
Numbers on the root cause explorer. Let's see. Which numbers?
On the right side of the filters.
So those are just times, date stamps, date time rather, excuse me, in Euro.
No, up at the top where it's like that region 1, account 1.
Oh, let me jump into it. Yeah.
If I see the answer, I'll tell you what it is. I don't remember.
So these numbers, come on. When I select a filter, it's just designating how many of that type I selected. So if I select that, that's region 1. If I select 2 IDs.
What's the choices?
Yeah, I'm looking for the question in the exam. Let me see.
It's events of interest selected, events of interest found, bottlenecks associated, or entities found by the search filter.
Oh, I don't like the wording on this either.
Is it entities found by search filter?
Yeah, it's yeah, I would select that one. Indicates the total number of entities found by the search filter.
That was my first impression.
Yeah, the wording, because it's just poor wording. That's what we're pointing it to. So it's another one I am noting down. Thank you.
have a question. It says like, what is the function of the icon highlighted in the screen capture? In the root cause explorer, it has like AWS host, and there's a button, right, which you can drag for on and off, and then it has another menu.
What's the which question is it? What's the text of it? I'll just try to
It
get it.
says, what is the function of the icon highlighted in the screen capture
Okay.
on a root cause explorer?
Just give me one moment to get to it. I just got logged out here.
And there's a slider. It says AWS and host, and it's a blue dot on a slider going left and right.
I'm showing it on the screen. Is it this one?
No, that's the one I had a question about.
Oh yeah, yeah,
earlier.
you were. Oh, here it
Um,
is. Here it is. Here it is. I'm sorry.
Yeah, that's the one.
That's it. Yeah.
Oh yes. Okay. So this will toggle all the filters in the row on or off. So if you switch it to the left, it turns all of AWS and host off. If you turn it on, then you can select the account ID, the region, etc.
Thank you.
Yep.
And
No,
I
thank
have
you
another
first.
one.
Sure,
Last
sure.
one.
No, of course.
It says match the root cause explorer advanced filter with its corresponding descriptions. So options are intensity, seasonality, impact, and stability. So root cause advanced filter with its corresponding descriptions.
I was just hoping to find the question here.
Yeah, last but one. Yeah.
Oh, this one.
No,
No?
the last but one. Yeah, that's the
Oh
one.
yeah, sorry. I'm okay. Oh wow, this is tough. Let's see. Oof. Let me pull up my service. I need. Let's. All right. So let's see. So impact is going to be positive or negative. Let's see. Stability. Oof. Let's see. These are tricky. It should give us what I'm trying to show here, or I was hoping to show, is it should give a little help icon of actually what it is. It's not working. That's too bad. All right, so let's see, stability. Oh wait, let me show. There's a better screen for this. I'm sorry. Or did you do this already? If you went through this, I don't want to. Here it is. So impact. I'm just trying to show it. So impact is EOI. Intensity is going to be the extent of drift from the expected value of the metric. The seasonality is going to be based on the 0 to 100 high low scale. And then stability is going to be the only one that's left. Yeah. So I would go with that. Yeah, that should be correct.
Sure.
Hey guys, I just want to check, see if you had any additional questions. I'm gonna need to step away a little bit earlier than I expected, but okay, then if it's okay, I'm gonna disconnect the chat, disconnect the session for today, and we'll certainly see you tomorrow. If there's any questions, please ask, but okay,
Sure,
so
Josh. Thank you.
yes, go ahead, Harjeet.
I'm good. So yeah,
Okay, good. I hope to see you tomorrow then.
thank you.
Okay, have a good evening or day. Take care.